This video was brought to you by Indently.io, learning Python made simple.
How's it going, everyone? In today's video, we're going to be learning about another very cool function provided by itertools, which is called chain. So to get started, we're going to import from itertools the chain function. And I'm also going to import from typing the iterator type, since we will be working with iterators here. So why should we use chain, or what is chain? Well, chain is a function that makes it much easier to chain lists or to flatten nested lists. And it also helps us keep our code memory efficient in the process. So let's take a quick example on how we can use chain. So first of all, I'm going to create a list of type integer, which is going to equal 1, 2, and 3. Then we'll create another list of type integer, which is going to equal 1, 1, 1, and 2, 2, 2. And finally, let's use that chain to chain these objects together. So we'll create my chain of type iterator, which is going to be of type integer and equal to chain A and B. And as an argument, chain actually takes args, which means you can pass in as many iterables as you want. It doesn't just have to be 2. If you have a couple more, you can also add C and D. You can add as many lists or iterables as you want. Now, when we print this, what we're going to get back is actually a chain object, an itertools chain object, because this is memory efficient and is in fact an iterator, which means to grab a value, we need to use next on it. So we can grab the next 3 values, and what we're going to get back are these 3 values over here. Now, an easier way to actually visualize what's inside this iterator is to convert it to a list. So my chain, or the list of my chain, is actually going to end up looking like this. As you can see, we combined both of these together into a chain object, which once again is incredibly memory efficient. Otherwise, obviously, you could just type in A plus B if you don't care about that memory efficiency, and you'd get the exact same result. Anyway, moving on, chain actually has a utility method which helps us create these chains from iterables. So what I'm going to do next is create something called myLists, which is going to be a list of type integer. And the reason I'm doing it this way is so that I can copy this and create a couple of lists here. So as you can see, it now contains the list of 1, 2, 3 and the list of 1, 1, 1 and 2, 2, 2. Now let's create my chain once again, which is going to be an iterator of type integer. But this time we're going to create the chain using the helper method from iterable. So here we can pass in an iterable that contains lists, and it's going to perform the exact same operation. Now we can print the list of my chain, and it's going to chain those lists together, which is quite convenient if you have a list of lists, or an iterable that actually contains nested iterables. So as you can see, creating chain objects and using chain objects is quite simple. But why would you want to do this? Well, to show you the benefits of using chain, I'm going to have to import 2 other pieces of functionality. So from system, I'm going to import getSizeOf to actually find out the size of an object in bytes. And from string, I'm going to import ASCII letters, which is just going to give me access to the alphabet in one variable. And that's going to contain both uppercase and lowercase ASCII letters, which as you can see would be quite a pain to type out. And actually it might just make more sense to print ASCII letters. So as you can see, it's all of this over here. And that's a very nice shortcut to know about if you ever have to use all the ASCII letters. They also have symbols or digits and punctuation. So as a side quest, explore the string module. It's quite useful if you ever need to use all of these characters. Anyway, what we're going to do here is create an iterator, which is going to be of type string. And all we need to do is type in iter and convert the ASCII letters to an iterator. Then with iter2, we're going to create an iterator of type integer, and that's going to be an iterator from the range of 1 million. Now, as always, we're going to create my chain, which will be an iterator of type string or integer, and that's going to equal the chain of iter1 and iter2. And I'm not going to print this out because, there's a million numbers to print out, but what we will print out is the getSizeOf. So getSizeOf iter1, and we're going to say that these are bytes, and we're going to do the same thing for iter2. And finally, what we're going to do is get the size of my chain, so we can see the size of each one of these objects. Now what you should notice is that they are all memory efficient because we are working with iterators. We have 48 bytes, 40 bytes, and 48 bytes. And 48 bytes is very small for something that contains so much information. It contains the range of 1 million, and it also contains all of the ASCII letters. Now what I'm going to do next is create something called extracted, which will be of type list of string or integer. and that's just going to equal the list of my chain. So practically what we're going to do is extract all of the ASCII letters and all of the numbers from our range and turn them into a list. So I mean, right now, if we were to print extracted, what you're going to see is a huge list because we took all the values out of that iterator object or out of that chain object. But the worst part is that we used a lot of memory for that. So if we type in get size of for extracted and we provide the bytes, you'll notice that once we extract the data from that chain object, we end up loading a lot of information into memory. So that's the benefit of using the chain object. We aren't loading anything into memory, but we're still performing all of the necessary operations with the data we already have. And that's practically the main reason to work with iterators and to use the chain object over a list comprehension or even a for loop. Typing in list1 plus list2 is quite simple and works surprisingly well if you are working with very small amounts of data. But if you're working with anything big and care about having a memory efficient program, opt in for chain. But yeah, that's actually all I wanted to cover in today's video. Do let me know in the comment section what you think about chain and whether you still have any questions regarding chain. But otherwise, with all that being said, as always, thanks for watching and I'll see you in the next video.